Hello and welcome to this video from Heybridge High School's Maths department. In this video I'm going to be focused on equations involving indices, including changing the base. So the first thing that we need to know when dealing with equations with indices is we need to know and be able to use these 9 rules of indices. So the first rule is the pair of n. So what this means is that we would have a number, let's say a to the power of n. All this means is that you will have a multiplied by itself for whatever number of n would be. So if you had a to the 2, that just means that you've got a times a twice because it's the power of 2. If it would be to the power of 3, it's being multiplied by itself a 3 times. So power of 0, so we've got a to the 0. So any number where the indices is 0 will be equal to 1. We have rule 3, the power of 1, so a power of 1, you will always equal a. So if you have 2 to the power of 1, your answer would be 2. It's just another way of writing it. Rule 4, the power of a negative, so you've got a to the minus n. So this means we can write it as a fraction. So we would write it as 1 over a to the n. Rule 5, the power of unit fractions. So this would be a to the 1 over n. So whenever we have a number to a fraction, it means that we can write it as a surd or the root of something. So it would be nth root to a. So n being the root that it is. So if n's 2, we are square rooting it. If it's 3, cubed rooting it, and so on. Rule 6, the power of non-unit fractions is when we have a fraction where the numerator is not 1. So it would be m over n. So again, as it's a fraction, it would be a root of something, or it's written as a surd. However, this time a would have its own indices. So we would still write n root a, but a would be to the power of n. Rule 7, the multiplication rule. So this just means that we have one number to the power of 1 unit indices times by another. So if we had a squared times a cubed, all this means is that we then add the 2 indices together. So you would have a n plus n. Rule 8, the division rule. So this is just the opposite of our multiplication rule. So we would have a to the m divided by a to the n. This time, instead of adding together, we take them away. So we would have a to the m minus n. And finally, our last rule, power of powers. This is when we will have a number to a power that is all to another power. So in this time, instead of adding or subtracting, we then multiply the numbers together. So it would be a n times n, or it can be written as a n m. So let's work through some examples. So we're going to be using the 9 rules that we've previously discussed to attempt to answer this question. So we've been given the equation x to the power of a half equals 10. So let's think back to our rules. Our indices is a fraction. So if our indices is a fraction, it means that it's the root of something. So currently, we could rewrite this as the square root of x is equal to 10. So it means exactly the same, it's just rewritten in a form that's a bit more familiar to us. So remember, when finding the value of x, we need to do the inverse. So it's currently being square rooted. So to do the inverse, we need to square both sides. So if we square both sides, we'll be left with x, and 10 times 10 is 100. And there we go, we have found our value of x. So our next example, we've got x to the power of 3 over 4 is equal to 8. So our indices is still a fraction, however this time the numerator is greater than 1. So this would be rule 6. So we can rewrite this as a root, but our denominator is a 4, so this would be our fourth root, and it would be x to the power 3, which is our numerator, which is all equal to 8. So they mean exactly the same, they're just rewritten in another form. So first of all, we've got the fourth root of x cubed is equal to 8. So we need to do the inverse. So currently we've got the fourth root. So the inverse of taking a root is to do the indices, to take it to the power. So we need to do, so it would be x cubed is equal to 8 to the power 4, which can just be rewritten as 8 times 8 times 8 times 8, which will give you 4096. So we haven't got x quite by itself yet, it's currently x cubed. So to do the inverse, we need to do the cube root. So if we take the cube root of both sides, so we would be left with x, and the cube root of 4096 is 16. So our next example is the cube root of 4x minus 1 is equal to 3. So remember, we need to do the inverse to find our value of x. So it's currently the cube root, so the inverse would be to do to the power of 3. So if we do that on both sides, we'd be left with 4x minus 1 is equal to, so it would be 3 cubed, so 3 times 3 is 9, 9 times 3 is 27. So this is just a standard linear equation then. So inverse, we need to add 1 to both sides, so we'd be left with 4x is equal to 28. And then x isn't by itself, it's currently being multiplied by 4, so if we divide both sides by 4, we will be left with x is equal to 7. Okay. Next example is x to the minus 2 equals 16. So we can rewrite this using the fourth rule. So we can rewrite it as 1 over x squared is equal to 16. So at this point we just need to rearrange. So currently get rid of our fraction. To do that we can times both sides by x squared. If we times both sides by x squared, we get 1 is equal to 16x squared. We need to get x by itself, so if we divide 16 on both sides, we'll have 1/16 is equal to x squared. And then x is currently being squared, so we need to do the square root. So if we square root both sides, we'll have 1 over 16 is equal to x. We can simplify this a bit further, our last point further, and we can rewrite it as square root of 1 is just 1, square root of 16 is 4, so x is equal to 4. But we need to be cautious because when we take the square root of something, we get the plus and minus solution. So x is a plus or minus a quarter. There is a step that we can take rather than doing this method. So we can always write it as a fraction here, but instead of doing this next step where we multiply across and then divide again, we could just write the reciprocal. So we could just have x squared is equal to 1/16, which then takes us to this step here, just saving you a bit of time. If you're happy to do this, that's no problem. It's just we could make this first step here and then carry on. So next question. So this point we need to be changing the base. So everything we've done at the moment, we have just dealt with the indices rules. This we're going to take it just a step further. We're still using our indices rules, but we need to be able to get our base functions the same. So what I mean by base functions is this value here. So in the example, we're going to be expressing the following in the form 3k. So our base value is 3. So if we look at our first example here, 3, how could we rewrite 3 so that it is in the form 3k? Well, rule 3 says that a to the 1 is always equal to a. So 3 to the power of 1 is equal to 3. So next example, rule 2, we've got a to 0 is equal to 1. So we could just write 1 is equal to 3 to the power of 0. Our third example, this is just, we need to be able to know multiples of 3, but we can see that 3 times 3 is 9, 9 times 3 is 27, so we should know that 3 cubed is equal to 27. So they mean the same, we are just writing it so that they are of the base 3. So our next example, so we've got the square root of 3. So another way of writing the square root is by writing it as a fraction. So we can write it as 3. It's the square root, so our denominator is going to be 2. And the power of 3 is just 1, so our numerator will be 1. So our next example, so this is what I mean by writing it as base 3. So first thing that we need to do is just change this 27 into something where the base is 3. So if we do the square root, what's another way of writing 27? Well, we've done this previously. We know that we could rewrite 27 as 3 cubed. So by writing the square root of 3 cubed, sorry, that should be a cubed, they are equal. However, this still isn't in the form of 3 to k. We can take this one step further. So what's another way of writing the square root? Well, we've done this in our previous step. We can write it as a fraction. However, this time, so it would be equal to 3. Our base is 3. Our denominator is a 2 because it's the square root. However, we've got 3 to the power of 3, so our numerator needs to be 3 this time. So it would be 3 to the power of 3 over 2. So our next example, so we need to write this, so our base needs to be 3. So what's another way of writing this? So we get a fraction. So rule 4, so we can do it as a negative power. So a negative power just means that we can write it as a fraction. So it would be 3 to the minus 1. So our next example. So first of all, we know our base is going to be 3. It's implied in the question. What's another way that we could write 81 where the base is 3? So we need to be thinking of how many times you can multiply 3 by 3 to get 81. Well, we know that 3 cubed is 27. If we do 27 times 3, that gets us 81. So it would be 3 to the power of 4 gets us 81. So we could rewrite it like this. However, that's not quite in the form that we need. So when we've got 1 over, remember it's a negative number, just like our previous example. So we can rewrite this as 3 to the minus 4. And our last example, so we want our base to be 3. We've got a square root. So what's another way of writing a square root? Well, it's writing it as a half. However, this is 1 over the square root. So The other way of writing 1 over a value is by having a negative indices. So these are just something that just a bit of practice of changing your base values. So they're all equal, they all mean the same, it's just they're rewritten in a different form. And we need to be able to do this because it will help us on more difficult questions. For example, when we have a question like this. So we know if our base values are the same, so if we have this equation, so it was a 5x is equal to a, that should be a, is equal to a 4 to the minus x. If the base values are the same, that means that their indices are the same. So then we can just make the step of 5x is equal to 4 minus x. So this is why we need to be able to change the base values so we can work and get the values that we need. As our variables are in the indices, we can't just rearrange. So first step to do is we need to change the base. So think of the number 2 and the number 8. Is there any way that we can get them that their base is the same? Hopefully that you've spotted that we can rewrite 8 to the 4 minus x. We can rewrite the 8 as 2 to the power of 3. And that is to the power of 4 minus x. So hopefully you've spotted that 8 can be rewritten with a base of 2. So if we're going with a base of 2, that means that the 2 to the power of 5x just stays the same. So we've got 2 to the power of 5x is equal. So here we've got our base almost the same. However, on the right hand side of the brackets we've got cubed multiplied by 4 minus x. So this is where we need to know the last 3 rules. So rule 7, 8 and 9. So this is actually rule 9. So we've got an indices being multiplied by an indices. So that just means that we can do 3 times 4 minus x. So we would have 2 to the power of 5x, so that stays the same. So we're multiplying the indices together, so we've got base 2, so 3 times 4 is 12, 3 times minus x is 3 minus x. So then this here is now in the form of this here, so it just means we can take that extra step and just say that the indices are equal to each other and we can find the value of x. So our next step here would be to write 5x is equal to 12 minus 3x. So we can find the values of x. If we add 3x to both sides, we'd be left with 8x is equal to 12. And then finally, if we divide 8x by 8, both sides will be left with 8 is equal to 12 over 8. And then we can simplify this, which is just 3 over 2. So there we have a value of x. Our next equation, so our x value is the indices, so we need to make that additional step of changing our base. So we've got the numbers 4 and 16, so can we think of a number in common, so a base number in common? Well, 16 we could rewrite. So we could rewrite this as the cubed root of 4 squared. So we'd still get 4x this side. So we've already done an example like this, so we could rewrite the cube root of 4 squared using the rule 6. So this can be rewritten as 4 to the power of, so our denominator is 3 and numerator is 2, and we have 4x this side. We still haven't done anything there, so our base values are the same, our indices are in the simplest form, so we can take the extra step and we can write x is equal to 2 over 3. And we don't need to do any more there because our x value has been found. Next example, so we've got 9 to the power of x is equal to a third. So we've got two numbers, 9 and a third. Can we think of a way of rewriting either of these so that their base values are the same? Well, we could rewrite 9 as 3 to the power of 2. Remember, it's being to the power of x, so we need to make sure we do that. And we could rewrite a third so that our base is 3. So what's another way of writing a third? We just write 3 to the power of minus 1. So we're not quite in our simplest form, so we just need to expand out the bracket. So we could do 3 to the power of 2x is equal to 3 minus 1, and now our bases are the same, it's all been simplified, so we can just write it as 2x is equal to minus 1, and then we just rearrange to solve to find the value of x. So x is being multiplied by 2, so what we do is that it's being multiplied, the inverse is to divide, so we divide both sides by 2, so we'd have x is equal to minus 1 over 2. And there's our value of x. Next example, so we've got the square root of 5 has been multiplied by the 5 to the power of x, which is equal to 1 over 25. So is there a base that is in common with 5 and 25? Yes, we could rewrite, first of all, we could rewrite our square root, can't we? We can rewrite it as 5 to a half times by 5 to the x, which is equal, so 25 we can rewrite as 5 squared, and then that's 1 over, so we can write negatives get us to write 1 over, so we could just, next thing we could do, we could just use the rule 7. So we've got 5 to the half being multiplied by 5x. So we can rewrite, and just two indices that are being times together is just adding them together. So half plus x is equal to 5 to the minus 2. So our bases are the same, we can't simplify our indices anymore, so we can just write it as a half plus x is equal to minus 2, and then we can rearrange to find our value of x. So I could take away a half on both sides, and that would get me as x minus 2 minus a half is minus 5 over 2. Okay. So our next example, we've got 16x all to the power of 2 is equal to a quarter. So looking at 16 and a quarter, hopefully we can see that we can write them to a base of 4. So 4 times 2 gets us 16. So we can rewrite 16 that way. That's to the power of x, which is all to the power of 2. And then we can rewrite a quarter as 4 to the minus 1. So a negative number gets us our 1 over value. So here we need to use our pair of powers rule. So we can rewrite this. If we do our outside first, so you'd have 4 squared all to the power of 2x equal to 4 minus 1, and then the next step we can do it again, so we'd have 4 to the power of 4x is equal 4 to the minus 1. So our base values are the same, we're in our simplest indices, so we could write it as 4x is equal to minus 1. So to find x we need to just divide by 4 on both sides, so x is equal to minus a quarter. Next example, so we've got x to the minus 3 is equal to 8. So let's just write x in another way. So not quite the same as our previous example of we need to change the base because our base is an unknown, but we can rewrite our left hand side as 1 over x cubed is equal to 8, and then we're left with a fraction, and when we got fractions we want to get rid of them. So it's currently being divided, 1's being divided by x cubed, so if we multiply by x cubed it gets rid of our fraction, and we've got 1 equals 8x cubed. And then again we need x by itself, so let's get rid of, it's currently being multiplied by 8, so if we divide by 8 we'll have an 8th equal to x cubed. And then x is currently being cubed, so if we do the cube root on both sides, so cubed root of an 8th is equal to x. And then we can simplify on the left hand side, because the cube root of 1 is 1, the cube root of 8 is 2, because 2 times 2 is 4, 4 times 2 is 8, is equal to x. So remember as well, if we don't want to do this step here of multiplying across, we can take the inverse. So we could write it as x cubed is equal to 1 over 8. So that's the same trick that I applied previously. It just means that you don't have to do these first few steps. So you should be able to know that when you've got x to the negative, if you take the inverse of the right hand side, it just saves you a few steps. So our last example, so this one can be quite tricky because it might be difficult to spot the base value which is common with the two numbers. So we've got 100 and we've got 0.001. So let's just start off with the left hand side first. So 100 we could rewrite as 10 to the power of 2, which is all to the power of x, and then that is being square rooted. Yeah. So another way of writing 0.001, well, that's the same as 1 over 1,000. Yeah. So with having 1,000 as our denominator, well, if we can rewrite 1,000 with a base value of 10, can't we? Because 10 cubed is 1,000. So we could rewrite that there as 1 over 10 cubed. So we're getting closer to where we need to be, but we haven't dealt with our indices completely yet. So let's look back at our left hand side. So let's multiply out our brackets. So get rid of the brackets, we don't want them there. So we've got the square root, but we've got 10 to the power of 2 all to the power of x, so we can write that as 10 to the 2x. And then right hand side, so we've got a fraction, so what rule do we know deals with fractions? We can rewrite this then as 10 to the minus 3. We're getting closer, just one more thing, we've got to get rid of that square root. So how do we write a square root? Well, our indices needs to be a fraction, so we can do 10 to the 2x all over 2 is equal to 10 to the minus 3. Can't do anything more on the right hand side because it's already in our indices. So hopefully we should be able to spot here that the 2 and the 2 cancel down, because 2 divided by 2 is 2. So we can then rewrite this just as 10 to the power of x is equal to 10 to the power of minus 3. Indices have been dealt with, our bases are the same, so then we can just write this as x is equal to minus 3. So there we go, answer found, x has been found, answer's all done for you. So that's the end of today's video. Thank you for watching.